Forcing all processes to see the exact same order on all updates may be an overkill. For instance, P3 and P4 here may perform completely different and independent computations with the values M1 and M2. And furthermore, the update to M2 had nothing to do with the value of M1. They were also completely independent. However, if we take a look at the second example, before the value M2 was written, the value of the memory location M1 was read. This means that there is potentially some relationship between the memory location M2, this particular update to the memory location M2, and this update to the memory location M1, given that this read operation that was performed at P2 just before this write returned the value of this write operation that happened on processor 1. There is clearly some flow of information, some potential dependence between these two updates that happened on two different processors. Based on this observation, clearly it is not okay for these two operations, this M2 update to Y and the update of memory location M1 to X, to be perceived in this different order. It would be very incorrect for somebody like P4 in this case to observe that the value of M2 was updated to Y before the value of M1 was updated to X. Like P4 here thinks that M1 is still 0, and then it finds out that M2 became Y. But there is dependence between the fact that Y was written to M2 and the fact that X was already written to M1. So clearly, this is not a reasonable execution. It will be very difficult for software to understand what exactly is happening with the memory if it cannot reason about dependencies like this. However, in this case, with such dependence that not exist, it will probably be okay for us to tolerate this kind of reordering. The consistency model that provides exactly this kind of behavior is called causal consistency. Causal consistency models guarantee that they will detect the possible causal relationship between updates, and if updates are causally related, then the memory will guarantee that those writes, those update operations will be correctly ordered. What that would mean is that in this situation where the two updates are in fact correctly ordered, we have to make sure that every processor observes that the update of X to the memory location M1 happened before the update of Y to the memory location M2. So we have to make sure that on P4, this first read of the value of the memory location M1 returned an X. In this case, this execution will be causally consistent given this particular relationship between the updates. For writes that are not causally related, or they're referred to in causal consistency as concurrent writes, there are no guarantees. Causal consistency doesn't guarantee anything about such updates, and they may perfectly legally appear in arbitrary orders on different processors. Just like before, causal consistency also makes sure that the writes that are performed on the same processor will be visible in the exact same order on other processors. Again, it would be too much of a challenge to understand how to really reason about a system if the updates from a single processor can be arbitrarily reordered.